Imagine taking some ice and turning it into steam. This is a 5-step energy calculation since there are 2 phase changes and 3 temperature changes, one for each phase. We're going to calculate the energy required when 10 grams of ice at -2, notice it's ice below 0, is converted to steam that's above 100 to 103 degrees Celsius. It's a 5-step conversion, and this is Screencast 12.9. Alright, let's consider what happens as we're heating it up. So you got a block of ice. It's 18 grams. That happens to be a mole. That would be a relatively small cube of ice. And those are the 5 phase changes. Heating up some ice, melting the ice, taking that liquid water and heating it from 0 to 100, boiling that liquid water, and then even heating the steam up a little bit. 5 steps. Okay, from -20 to 0, we can apply Q equals mc delta T, where m is 18 grams. C is the specific heat of, check it out right here, solid water, by night known as ice. It takes about 2 joules per gram, so that's right there. And temperature change is 20 degrees. That's our delta T. So we plug those in, multiply them in, and we get 731 joules. Now it melts. It's at 0 degrees, and that 18 grams is melting. Melting takes 334 joules per gram. It should just be 334 times 18. 6,000 joules. Isn't it interesting that it took a lot more energy to break up that lattice than it did just to heat up the cold ice? Now we got some water, and it's going to do the full enchilada from 0 to 100 degrees. That's as far as it can go as a liquid. MC delta T. M is 18 grams. C this time is liquid water, so about 4 joules per gram. Delta T, the whole 100 degrees. Multiply them together and we get a very large number, 7,524 grams. It's dominating at this point somewhat. Now we've got some liquid water at 100 degrees, and it's going to change phases from liquid water to steam. There it is right there. It takes 2 joules per gram, so it should be 2 times 18. It takes 2,260 joules to boil each gram, and we've got 18 of them. This is going to be a whopper. 40,000 joules. So by a factor of about 5, this is the dominant feature right here, step 4. Finally, it goes a little bit above, from 100 to 103 in the form of steam. Q equals mc delta T should do it. M is still 18. C this time is in the steam form, so we're going to use that number right there, 2 joules per gram. And it's 10 degrees, from -20 to 110. Not sure that was the problem we asked before. I thought I asked like to 103, but here it is, from -20 to 110. Total them up, and you get 58,565 joules. These are the 5 steps that we use to calculate how much energy it takes to go from cold ice to hot steam. You could do the same calculation if you're going downhill, use the same numbers, only they would be negative. Enthalpy of heating up some water.